Viitorul e al tău, noi punem temelia. UDCP, construim pentru România. UDCP, Universitatea de Construcții București.
Okay. So I will present you the result of a study we performed within our geotechnical design team at Societatea. I just forgot to add a logo and names. So this is a teamwork result, and also together with Professor Horatiu Popa, who is mentoring us for most complex projects and for such research studies. Well, needless to say that for complex geotechnical problems, for soil structure interaction, we need parameters such as initial shear modulus or shear wave velocities, but the result of our study is more focused on the initial shear modulus, as we also use this for design of retaining structures. We all know we can obtain this either from in situ test or laboratory test. Most of the results we have from site test, especially downhole tests performed in the boreholes. And of course, we hope to obtain some correlations for these important parameters with simpler laboratory tests or in situ tests, which are more economical and easier to obtain. Usually we prefer in situ test because there is less or no disturbance of the soil samples, and we have a better coverage of the investigated volume. And most common tests we did are downhole tests, but sometimes also seismic cone penetration or seismic dilatometer tests. And as I mentioned previously, there is also a focus to obtain some correlations through indirect methods with simple laboratory testing. For those of you that are not familiar with lithology in Romania, and especially in Bucharest, because this is the area where we have most data obtained and for bigger projects. After a filling layer, we have the Bucharest clays, usually stiff silty clay deposits. Then we have Colentina gravels, which are actually sands with maybe small parts of gravels, usually medium dense. Then the intermediate clays, again quite stiff, and sandy clays. These are the most relevant layers that we need for our usual geotechnical problems. And this is the database we have with obtaining small strain shear modulus. Coincidence, we have 23 sites, like you have, Christy, although there is only partial overlapping for the projects we perform together. We don't have results from other projects you performed, but we have from projects we had with tests performed by others. And this is most probably a reason why we have this big data spread. Of course, part can be justified by different soil conditions, because if the soil was so uniform from one part of Bucharest to another, we wouldn't have to perform soil investigations. But from 1 time to 5 time difference, it is obvious that this is also due to the testing method. Here we have downhole tests, most of them for some sites. We also have 2 or 3 downhole tests or crosshole tests, and a few seismic seismic dilatometer or cone penetration test. So after excluding the values that were obviously out of the range, this is what we obtain for the three main layers in Bucharest. And this is statistical processing of the results. We remain with 17 values. The green dotted lines are characteristic values obtained through mean characteristical values through statistical methods. So we see for Bucharest play we have plus minus 20 megapascals from the average of about 100 megapascals. For Colentina gravel we have plus minus 30 from the average of 190, and for intermediate clay about plus minus 45 from the average of 280. We also try to obtain some correlations between the shear modulus and void ratio. We've seen in many references in the literature that this is a parameter with which the initial shear modulus is related to. However, and this is just for the Bucharest clays with several formulas. However, we didn't find the good correlations, although other authors reported good correlations. But when we compared with the deformation modulus obtained from SPTs, yes, we like SPTs very much, and we see they provide very good correlations for non-cohesive soils. So we obtain even better correlation coefficient than other authors, but with a note that the actual value with this correlation is about 70% of that obtained from in situ tests. So we can just consider to correct, but it's obvious this is a good direction to identify further. So to conclude, we saw that the variation of the initial soil modulus is very important, so we should be very cautious in considering this data and check how they were obtained. Besides from the differences in the soil layer parameters and thicknesses, it is intuited that also the variation of the testing procedure is a reason for obtaining such a big spread. We all know this is not a standardized method. There is no standard and very few literature references on how to perform these tests. Also, we don't have any control of quality control of the testing equipment, sensors, calibrations, and so on. But it's also most probably the art of the people or software doing the processing of the data obtained. In terms of correlations, future research is worth trying to obtain such correlations, although for cohesive soils with laboratory parameters we couldn't yet find something to get close to. But for cohesive soils based on SPTs, the results seem promising to continue researching in this area.
Viitorul e al tău, noi punem temelia.